Have you ever had an old car part you just can't replace? I lost this badge off the fender of my old van about 15 years ago. It's probably somewhere alongside I-90 between Madison, Wisconsin and Boston. Now, replacements for this one are super common, but what if they weren't? Or what if I didn't want one with 40 years of decay? Or even better, what if I wanted a custom one made out of solid metal instead of plastic? So I'm gonna do what any reasonable person would do. I ripped this one off the other fender of my van, and I'm going to 3D scan it, recreate it digitally with some changes, and cast myself a new one in solid metal right here in my garage. Honestly, it's way easier than it sounds. The cool part is it's not just about badges. 3D scanning is an insanely useful tool for restoring or customizing anything. You can match parts that aren't made anymore. You can make custom pieces that will fit exactly like an original part, reverse engineer brackets or interior bits, a whole bunch of stuff. Once you can capture a part with a high level of accuracy, suddenly you can fix, replicate, or improve almost anything, digitally anyway. We'll get to the physical part in a minute. To scan this thing, I'm using this. This is the Revopoint Metro Wide Pro. This is a blue laser scanner built for high precision mechanical parts. Perfect for little angular things like this badge. Most scanners I use rely on stereo cameras, 2 cameras spaced apart, kind of like your eyes to get a sense of depth. This also shoots out a laser, and it looks at the distortion in the line of the laser using those cameras to get a much more accurate image. It gives you especially clean images on things that are very, very precise or finely detailed. Revopoint sent me this, and I tested it out on a whole bunch of different things before scanning the badge. A couple of things surprised me. Despite the marketing showing a big muscly guy with sleeveless shirts on, it's actually very light. You know, you don't have to go to the gym or anything to use this. And also these buttons that are on the back, especially this start, stop, pause button, they're far more useful than I thought they would be. I kind of want this on all scanners now, especially the pause one. For some reason, it seems blind to the color red. I scanned the pinnacle of modern precision manufacturing, Lego. This gray plate scanned great. I got the stud spacing very good. It didn't quite get the Lego text, but it looks amazing. But the red Lego, basically invisible. I tried multiple modes, no luck. Then it hit me. Blue light is absorbed by red objects. The scanner literally cannot see the laser. If it did reflect blue light, this would be a purple Lego. The secret turned out to be white matte spray that we're going to talk about in a minute. That plus the auto turntable mode resulted in a shockingly good scan. The edges of the part came out extremely crisp, and you can almost make out the Lego text on top of the plastic studs. It almost looks like the bumpy texture showed up in the final model. That's crazy. These letters can't be raised more than like 1/10 of a millimeter, and you can still see them. This thing is incredible. The badge had the opposite problem. It's shiny. Very shiny. The scanner still picked up the shiny surface, but not perfectly. A little matte scanning spray fixes that. There's 3D scanning spray, but if you don't have any of that laying around, go into your bathroom and swipe your wife's dry shampoo. Not shiny anymore. That works too. Shockingly well, as it turns out. It doesn't sublimate away like scanning spray, but you can just wipe it right off. I scanned both sides, the top and the bottom, to make sure I get these locating pins in the right location. I was using Revopoint software to clean it up. There's a one-click option that works surprisingly well, or you can kind of go through the steps and do it a bit more manually. That's what I did. I won't go through every feature in the software, just the parts that matter for this project. Up at the top, you're gonna see a point cloud edit section. Fusion is what you gotta do first. There's a fast and a high quality fusion. That's self-explanatory. And then there's a slider. Just know the smaller the point distance slider, the smaller the number, the more detailed it will be and the larger the file size will be. Then you can use the isolation tool next to that. Gets rid of some floating points. That cleans it up a bit. And then I use the crop tools on the far right to select anything I don't want and I delete it, like the table this thing is sitting on. This table, by the way, is excellent. It comes with a Metro Wide Pro. It already has the little reflective dots on it. It's motorized. You can have it kind of work automatically. It's very cool. To the right of the point cloud setting up top is a mesh edit section. The smaller the grid size on the mesh slider, the more detailed the mesh will be and the larger the file size will be. The isolation tool here also works, but the fill holes tool is probably the most important. It fills holes in the mesh. I did not use the simplify or smooth tools because I wanted the detail to stay, and this part is so small that the file size wasn't too big anyway. Merge is a cool feature where if you have multiple scans of different sides, it will actually take those meshes that you've processed and combine them into one solid part. I didn't do that for this badge, but it is neat. For this project, I actually didn't want a perfect copy. I wanted a sand castable version. So I exported the mesh as an OBJ and I stuck it into Blender, good old free Blender. The original badge is injection molded plastic. You can tell pretty clearly by looking at the back and also by the shape. But if I'm turning this into solid metal, sand casting needs slightly different geometry. More draft, fewer razor thin gaps like on the number 5 here. Features that I can more easily pull this out of the sand without tearing up the mold. The scan made it very easy to match the proportions. I was also able to get the locating pins in the right area and make them the right size. I did have to edit the shape just a little bit, like I said, to make it sand castable, but I didn't have to change the way it looks all that much. Once the digital pattern was ready, I 3D printed it on a Uniformation GK3 Pro resin printer. Any 3D printer will do. I just like this one because you get really crisp edges with a little less bloom effect. You don't have to worry about that. Personally, I just like how this printer has a little drip tray. You put the vat on the side and the resin drips back into the vat. You don't get a mess all over the place. I hate cleaning up resin drips on the floor. That resin drip feature alone, it's amazing. I wish everybody had one of those. Okay, digital model done, pattern printed. Let's turn it into metal. I'm using sand casting for this. It's one of the oldest casting methods out there, literally thousands of years. And honestly, it's way more accessible in a home workshop than people think. You don't need a huge foundry or some giant setup. You just need a small flask, some really good sand, and a process designed for good results. If you've got a garage, a small workbench like this one, you can do this. This badge is small enough I can use the smallest flask I have and a very small amount of sand. The general idea is simple. You ram up the sand with the pattern in there, you take the pattern out, in this case the badge, which leaves a hollow space inside the sand. Then you pour metal, liquid metal, into the hollow space through some gating of some kind. It cools, it solidifies, you now have the part. That's the theory, right? But getting the best results means paying attention to all the details. Otherwise you get cracks, sand trapped in there, or air bubbles, cavities, lots of stuff like that. It isn't harder to do it the right way at all. You just need to know the process. All right, and here we're gonna do the pour. Wish me luck. Not what I planned, but thankfully this is a low temperature metal. I poured this in an alloy called ZA12. It's one of my favorite casting alloys. It's a zinc and aluminum alloy that's used in tons of stuff. Zinc alloys are everywhere around your house, probably right now, especially if you're really into model cars. Then there's a lot of zinc around your house. Whoops. Good reason to use ZA12. If that were bronze, this would be a bigger issue. But then again, if it were bronze, I would be pouring with this up on the raised steel platform thing, not this. Not right over wood. This part came out of the sand looking pretty good. No holes, no cracks, no trapped sand. It's got the nice sand texture all over it. Now it's just as easy as sanding and polishing anything else. Cut it off the sprue, sand down the raised top with finer grit, and eventually I made my way to a polishing wheel, just a Dremel polishing wheel. I'm only doing the top surface with the sanding and the polishing for a reason. That reason is not laziness. See, these numbers have grooves, and you see the bottom of the groove in the original part? It's kind of like a coarse sand texture. That subtle sand texture doesn't show up in the original scan either. I mean, how would it? The dots are the size of a grain of sand. You probably didn't even notice that texture until I just pointed it out. Sand casting naturally creates that texture all over the part. So if I only polish the raised surface, it will be shiny like this one, and the recesses will be sand textured. Kind of cool, right? Okay, and if I wanted to be totally accurate, I would also polish all the sides of all the letters, including inside the hole. I'm not made of time, okay? Give me a break. And here it is. Original 3D print solid metal. For reference, here's the original one. I didn't get the dimensions exactly correct. I kind of like the metal one better. The ultimate test, does it fit into the same locating pins? Yes, it fits perfectly. The color is a little different from the plastic badges. I'm gonna have to make a metal Econoline badge next, I think. I think it looks pretty good, except for trying to keep fingerprints off of this thing. Man, chrome gets fingerprinted quick, doesn't it? If you want to check out the scanner that I used, the Metro Y Pro by Revopoint, I'll leave a link below. It's been great for small mechanical parts like this, even though it's not a tiny part specific scanner. I could have done the whole car fender in this thing. The laser detail is just amazing. And if you're curious about the metal casting side of this workflow, I put together a free starter guide with all the equipment and the setup you need and some tips to get you started sand casting. Links to that are down in the description and the pinned comment below. Thanks for watching, and let me know down in the comments what you want to see me scan and cast next. Maybe something bigger than a tiny, tiny badge. Let me know. See you next time.